The other big thing that we are going to do with radians is to evaluate those different trig functions if our angle measure is given to us in radians. So that's what we are going to see in example 2. Evaluating in radians. And my problem here, I want to find the values for all 6 trig functions of 3 pi over 4 radians. Now to find those 6 trig function values, I do not want to convert this angle to degrees. I do not want to convert from radians to degrees here. What I want to do is try to figure out what is this 3 pi over 4 radian angle going to look like. So we draw our coordinate plane, just like before. But instead of labeling these as 0, 90, 180, 270, let's think in radians. So I can call this 0 or 2 pi radians because 2 pi radians is the full circle. Half of our circle would be pi radians. Half of pi radians would be pi over 2 radians. And then 3/4 of our full circle, 3/4 of 2 pi, or a pi and a half, is 3 pi over 2. All right, so to figure out where this 3 pi over 4 radians is, we have 3/4 of a pi. Okay, because these are the same thing. So I want to go 3/4 of the way to pi, 3/4 of the way there. My angle is going to look like this. And then if we draw our angle down to the x-axis here, we get our triangle that looks like this. Now, if we are 3/4 of the way to pi, we're halfway between these two marks, between our pi over 2 and our pi, which means we just made a 45, 45, 90 triangle. And if we label our side lengths with what we know, with our special right triangles, our legs are each 1, and our hypotenuse is the square root of 2. But since we had to go to the left, this is a -1. We're above, this is a +1. And then again, hypotenuse is always going to be positive. So we got our triangle labeled. Now we have to find the values for those 6 trig functions. So we need to find the value of the sine of 3 pi over 4, the cosine, the tangent, and then my other 3, the reciprocal trig functions, are secant, cosecant, and cotangent. Okay, let's start off with the sine. Sine is opposite over hypotenuse. And opposite over hypotenuse, from our 45-degree angle here, our opposite is 1. The hypotenuse is the square root of 2. We just have that issue where we have that square root in the bottom, so we have to rationalize our denominator, and that simplifies to the square root of 2 over 2. So the sine of 3 pi over 4 is the square root of 2 over 2. Cosine is adjacent over hypotenuse. The adjacent is -1 over our hypotenuse is the square root of 2. And again, we have that radical on the bottom. We have to rationalize your denominator, giving us negative square root of 2 over 2. Tangent is opposite over adjacent. Opposite is 1. Adjacent is -1. Our tangent's just -1. Now we have those reciprocal trig functions. Secant, the big thing is remembering what secant goes with. Is secant the reciprocal of sine, cosine, or tangent? It's either sine or cosine. the reciprocal of cosine, because keep in mind, each one has to have a co. So I want to know the hypotenuse over the adjacent. Hypotenuse is the square root of 2. The adjacent is -1. So that's the negative square root of 2. Cosecant is the reciprocal of one of these ones. Okay. So these are my three main, the three original. Cosecant is the reciprocal of one of these. Cosecant's the reciprocal of sine. So it's the hypotenuse over the opposite. So the hypotenuse is square root of 2 over the opposite is 1. And then the last cotangent, cotangent's the reciprocal of tangent. So I need to know the adjacent over the opposite. Adjacent's -1. The opposite is +1.